Wait, is cosine over sine is tangent?
You got 3 cosine
Or is that sine over
negative
cosine?
sine theory. Yeah.
Wait, isn't it sine over cosine is tangent? So it's cotangent.
It's cotangent. No, that's tangent.
Yeah, no, it's cotangent. Yeah, exactly. Yeah, it's cotangent.
Oh wow! How do you do that?
Wait, Kevin, did you just say that this equals 0?
Yeah, so you want
But it's at like 90. It's at like pi over 4 and 3 pi over 4, right? Wait, do you get like pi over 4? Oh, it's pi over 2. Shouldn't you get 0 plus 2 pi k then?
Yeah.
Wait, that's
Yeah,
should
no, it's 2 plus pi k.
Yeah,
No,
you get 3 cosine t.
Yeah.
What's the equal 0 at? What? It's equal 0 at pi over 2.
Wait. But
You don't have to, this equals 0. This over this equals
yeah, I know. But you know for sure sine equals 0. Yeah, it's never. Yeah, you're right.
Tangent line is really
But t is equal to 0 now?
I said t is equal to pi over 2 plus pi k.
No, for b. Oh, never mind.
Wait, no.
2 negative sine t.
It's still not 2 pi k though, because
No, pi.
yeah, but either way, it's because
Not t.
Isn't-
I had t. My
isn't cosine of 0 just 1?
Slope is negative 1.
Yeah, but it's pi over cosine of pi over 2 0.
Yeah, that's 180 degree. Oh,
No, it's cosine of pi over 2 0.
Oh, right, I'm
90
retarded.
degrees.
okay, that makes more sense. Yeah, that's
Wait, where's negative?
Yeah.
Sine t equals 0. Sine t equals 0.
Sine t
So
equals
you just got
Sine t equals cosine.
and 3 pi over 2
no,
plus 2
so
pi k.
Kevin, you got
No, wait, but then we can't solve that.
isn't it at 0 and pi?
Tangent line
0 plus pi k. So just pi k, right?
cotangent of 0 is
What's English tangent of 3 halves?
Wait, why are you doing that? Wait, you just remember vertical tangent's the bottom.
Yeah, I know.
So it's
Oh, yeah. No, I did that.
I was like,
Yeah, see, it's 0 versus pi k.
Yeah.
or just pi k. 0 plus pi k.
Dude, 0 plus pi k. He's gonna like waste it.
Find all.
You should. I think using cotangent makes sense.
Find all points such slope is negative 1. Oh, 1 sec.
Slope is. Oh, that's just 45. Yeah, it's just 45. 45, 135. Because it's cotangent.
Yeah, cosine.
So it's just 45,
Or
135.
tangent.
No, it doesn't matter. 45.
Yeah. I think. So
However-
wait, you have 2 sine t equals 3 cosine.
Well, I already have negative 3 over 2 cotangent t equals 0.
Negative 3 over 2 because it equals negative 1, but you have negative 2 sine t, right? Because it equals negative 1, the slope is equal to negative 1, but you have negative 2 sine t, so negative goes positive.
It doesn't matter. You're looking for 0 versus.
Oh,
You're saying
okay,
these are
so
equal to-
no, you have to plug in the t.
Yeah, Yeah.
Wait, what are you?
You have to plug in.
Oh, you're doing D.
Oh, and just find where it is.
C is when it's equal to 0.
No, that one's B.
Or undefined.
No, that was B. B is
Oh.
that one. C is where it equals -1.
No, wait, it's just when it equals 1.
Wait, Kevin, wait, that's equals 1.
Yeah. It's where it equals 180.
Wait, Kevin, so
We were solving for 0. It should have been 0 is supposed to be the answer.
C.
Did you get this for speed?
Well, listen up.
You're not supposed to find the speed.
Why?
The last one? Oh, I there.
Oh, okay.
So he closes the tab too fast. Wait, what was the? What was the third question? I think it was like, is it slope -1?
Yeah, it's like find all points where slope is -1.
Oh, okay.
And then the last one is find speed when t equals 3. How fast is it moving when t equals 3?
So I mean, cotangent t equals 2/3.
So we have
-2/3. No, positive.
Wait, what?
Wait, what did you get then?
For which one?
For that question?
For speed?
No. When it's -1.
Oh, I didn't do that one.
Inverse cotangent.
Sine over cosine.
Well, I got inverse cotangent 2 over 3.
I got 3 over 2. So,
Okay.
3. What is?
That's what you're supposed to be looking for, not that.
In case you didn't follow along all that, I'll scroll. Slope, dy dx, that's dy dt over dx dt. So take a derivative of y with respect to t. Y is 3 sine, derivative of that is 3 cosine. Take a derivative of x where t is the variable. Here's x as a function of t. The derivative of 2 cosine t is -2 sine t. You could simplify that to -3/2 cotangent, but I think that makes your life a little worse, so I'm not going to do that.
So it'd be pi
We
over
want to find
2
out when the
plus
slope
2
is
by
0.
k is
So I want the slope to be 0. So 0 equals 3 cosine over -2 sine. If I want a fraction to equal 0, the top has to be equal 0. However, the bottom must not equal 0. That doesn't have an impact here, but there could be problems in your future where that's a problem. For example, what if I calculate a derivative and I find out the derivative is t squared minus 4 over t minus 2 t plus 7. That would equal 0 if the top is 0. Well, 2 makes the top 0. But see how it makes the bottom 0 as well? If I start here and I rise 0 and I run 0, okay, I just did it. What's the slope of that? Not much slope there, is there? Okay. But if I do a rise 0, run 7, okay, well that's the slope of 0. So if the top is, I let t equal -2, then you get 0 on the top, and the bottom you're going to get like -4 times 5, like -10. So, yeah, that works out great. Rise 0, run -10. That's the slope of 0. Okay. So be careful. I didn't do that here, but I can see myself doing that. Do you see me doing that to you on the test possibly, maybe? Be careful. Don't just focus in. Don't just log in on get 0, top must be 0. Yes, that's true, but also bottom can't be 0. Once I got that done, I'm going to solve some stuff. So I want 3 cosine t equals 0. Here it is. And my favorite way to do this is a long time ago. It's a nice little recap of the first half of the year, but I draw pictures. I want to draw a bunch of triangles where the cosine of each of those triangles is 0. And please notice that the sine of this triangle, that triangle, that triangle, that triangle, the sine of all those triangles, none of them would be 0. So we're safe. All right, now I'm going to list every possible answer. There's pi halves, there's 3 pi halves, there's 5 pi halves, there's 7 pi halves. Don't forget negative pi halves, negative 3 pi halves, negative 5. There's an infinite number of answers. It's pi halves plus pi k. Or pi halves plus 2 pi k, 3 pi halves plus 2 pi k. Long time ago. It's been a long time. But it was definitely a time where you knew how to do all that. There's pi halves plus 2 pi k, negative pi halves plus 2 pi k. I kind of like both. Some people really like to shortcut it, and they just want to do pi halves plus pi k. I don't recommend that, because there really are two different triangles, and we care about both of these triangles, and here's why. This is not the answer. I didn't say just give me all the times. If I asked for all the times, it would be pi halves plus pi k. That'd be great. But I don't want all the times. I wanted all the points. T is great, but I wanted the points. I want the x value and the y value. I want the point x, y. So take those t values, those infinite number of t values, and plug them in. If you put in 5 halves, pi halves, 5 pi halves, 9 pi halves, negative 3 pi halves, all of those different ones in, you get this red triangle. In every single situation of that red triangle, the cosine of that red triangle is 0. So the x value is 0. There's another set of infinite answers. The 3 pi halves, the 7 pi halves, the negative, I don't know, I lost it. Negative pi halves, negative 5 pi halves. Those all look like this. And in every single situation, cosine is 0. So I guess it doesn't matter after all. But you see how it mattered for the y value? So you get an infinite number of times, but there's only 2
Speed
points.
at 3.
Think about what these parametric functions look like. They're kind of doing something like this. They just keep traveling around. And there's 1 point here, and then there's 1 point here, where it's hitting that thing I wanted it to hit. So it might happen an infinite number of times, but there's only the 2 points. Later on, I think you should graph this thing and kind of make sure it makes sense that 0, 3, and 0, negative 3 would be points where the slope is 0. If you haven't graphed it yet, maybe at the end, when you're done doing the whole thing, graph it. If you already graphed it, awesome. That's a great way to check your answer. But I'd rather you not kind of look ahead. I'd rather you kind of do the work first, then graph it to verify. So move on to part B if you haven't already. When you're done with part B, feel free to do C. And you know what? What the heck? Maybe do D later.
Yeah, equals this 3 equals that. Yeah. So I got 3. Okay, 4 cosine squared t plus 4 cosine squared t equals
And then, yeah, and then 4.
Wilson?
No, you can factor out cosine squared plus sine squared. So you have 4, so it becomes 4 plus 5 sine squared.
This is basically
Or you could plug it in your calculator.
no, dude. I don't care how this works. How does it show that this one equals 0? I separated 9. This is 4 plus 5.
Wait, let me see. Oh, yeah.
What? 4.
You need to put the parentheses.
Okay, sure. That becomes 4.
Yeah,
To be 0.
So it's 4
No, that doesn't help. What I want to do is
5 at 0.
you're doing it wrong. You know, it's T. You're doing it wrong. I want to show on the calculator. T equals 3.
That's what I did first. And I couldn't, this was my answer. Like, I
Yeah,
didn't
you
know how
don't
to
really
get past
simplify
that.
it.
Yeah.
Maybe I.
So this was my answer originally. I didn't, no, with with 3, I put 3 here. This was my answer.
I want to show that pi half is 0.
Yeah, but what's it, right?
Well, it doesn't look right.
Yeah, it's true.
That's why I think.
Because, but it makes sense. I mean, you follow here.
And then you just put C. I get it. I don't really know. Let's
Okay,
explain.
plug into calculator.
Oh, I think you might have supposed to be put 3 in there. I'm not sure.
Well, it says T equals 3, so I think you put T.
Yeah, I think you're right actually.
It's pi plus 2 pi k and 2 pi. Oh.
Like, because it wouldn't make sense to have more.
Cool.
Yeah, I think this is it.
Cats. The
It's
answer's
weird
cats.
answer. 4 cosine squared 3 plus
Jeffrey.
square root of 3 to the 1/2 power.
I mean,